Well, hello, and we've got an exciting topic for you tonight. Tonight's what we call the power rule, and you're really going to appreciate the power rule after taking all that time and using the definition of the derivative. So basically, the power rule provides us with derivative shortcuts. So take some great notes and really appreciate that we're not writing out that huge definition every time. Alright, so our first derivative shortcut is the derivative of any constant is 0. Now notice the notation, this d dx. Again, this implies we're taking the derivative. C, they're telling us, is a constant. So not only, again, do we need to get used to writing this notation, but also reading it. The derivative of a constant equals 0. Now this should make perfect sense. Let me give you an example of a quick function. Let's say f of x equals 4. And you were asked to graph that function, which is something we all can easily do. Basically, I'm just graphing the line y equals 4. Okay, now, we're talking derivative, so what are we asking about? We're asking about the slope. What is the slope of any horizontal line? Well, remember, that slope has 0 rise, so it has a slope of 0. Alright, so this constant rule should make sense. The derivative of any constant is 0. Now, let me throw a sneaky one at you. When if I asked you for the derivative of pi? What would you have to say to yourself? Well, pi is really 3.14159, etc., which is a constant, so its derivative, remember, is 0. Okay, so don't let them fool you on those little things. Second rule is the power rule. All right, so it says the derivative, okay, of a variable to a power is equal to, take that power, bring it down in front, x to the n minus 1. Let me run through a few examples. Let's take the derivative of x cubed. Okay, the power rule says it's nx to the n minus 1. So it's going to take that n exponent, it's going to bring that 3 down, x to the 3 minus 1. So I'm going to say that's really 3x squared. Now again, I'm just trying to write the steps out. If obviously you can subtract 1 in your head, I would encourage you to do so. You don't need to show the minus 1, but I just want to stress that we're subtracting 1. Let's say the derivative of x to the 7th. All right, see what you get. Hopefully you're rewriting 7x to the 6th. Take that exponent, bring it down, subtract 1. How about the derivative of pi cubed? Take 20 seconds, get me an answer. Did you write 3 pi squared? I hope not. Think about it again. What is pi? Pi is a constant. So this is actually incorrect. Remember, this is a number to a power, which is just a constant, so its derivative is 0. So let me stress this rule again. Notice that my base, okay, my base here, this x, has to be a variable. And maybe let's put a note in there. That's a variable raised to a power, not a number to a power. Number 3, the constant multiple rule. Basically, if you have a constant in front of a function, it's just that constant times the derivative of that function. So again, let me give you an example. If I said the derivative of 5x to the 4th, okay, now I have a constant in front of the function. Well, you're going to do the same thing you were doing. You're just going to leave that constant alone. Okay, I'm going to leave the 5 there, and I'm just going to take the derivative of my x to the 4th, which is 4x to the 3rd. Okay, so I have my constant in front, just like I did here, times the derivative like I have there. And lastly, I would clean it up. 5 times 4, of course, is 20, x cubed. Let me throw the derivative of, let's say, 16x to the 5th. Pause it, try it on your own, see what you get. I'm going to say leave my 1/6 alone. The derivative of x to the 5th is 5x to the 4th. And now let's just watch our multiplying. Remember, when you multiply fractions, you multiply the tops and bottoms. Now 5 is really a fraction. Every whole number can be a fraction. It's that over 1. So the top gets me 5 over 6, x to the 4th. All right, our fourth and final rule is the sum and difference rule. So basically this rule says if you're taking a derivative of a function plus or a function minus another function, basically take the derivative of the first one, then put your plus or minus sign, the derivative of the second one. So again, let me give you a quick example. If f of x equals, let's say, 4x cubed plus x squared plus 6. Okay, notice I have a function plus a function plus a function. It says just take the derivative of each term. So the derivative, watch my notation out here, of f of x, of course, is f prime of x. And now I'm just going to take the derivative of each term. That's just my constant, so I'm going to leave my constant. The derivative of x cubed is 3x squared. Plus, this becomes just 2x. And here is a constant, so its derivative, of course, is 0. And I do not need to put a plus 0 there. We all know what that is. As I clean this up, I get a 12x squared plus 2x. All right, here we go. We're going to run through a bunch of practice problems together. Now, the most important rule you can say to yourself is rewrite. Okay, 90% of the time, we're going to rewrite our equation first. So what do I mean by rewrite? Well, the first thing I'm going to do is rewrite this function so I see everybody looking like the power rule, which is a variable to a power. Okay, and you'll notice I don't see that in the first example, this radical x. I don't see a variable raised to a power, so my goal is to rewrite that. And hopefully you all recall from your algebra days, this is really x raised to, what type of root is that? Square root, so I can call that a 1/2 power. Not x squared, of course, the 2 goes on the bottom. And then these guys are a variable to a power, so life is good there. And again, I have a variable to a power, so life is good. Once I've rewritten it, now we'll derive. And remember, when we derive, we get the derivative. So the derivative of f of x is f prime of x. Okay, that power rule says bring your exponent down, 1/2 x. Now remember, you have to subtract 1. Now when I have a fraction, I don't like to put minus 1 after my fraction. What I'll put is I'll write my 1 as a fraction itself. And what do I mean by that? Well, this guy has a denominator of 2, therefore I'm going to subtract 2 over 2. Would you agree that's really 1? Just like 3 over 3, 4 over 4. I'm going to subtract 2 over 2 so it makes my math easier. So now I'm going to say 1 minus 2 is negative 1/2. All right, if you didn't catch that, let me try it on the next one. Plus, I'm going to take that exponent 2/3, bring it down in front. X, now again, I have to subtract 1 from the exponent. I'm not writing a minus 1 because it's not a whole number. I'm going to say minus 3/3. Okay, again, 3/3 is 1, and it has a denominator of 3, which makes my math easy. 2 minus 3 is negative 1/3. Bring this guy down, so minus 3/4 x, and this time I'm going to say minus 4/4. Now just watch your math. Negative 3 minus 4 gets me a negative 7/4. And there you go, you have your derivative. Now, what gets tricky about the AP? Well, the AP doesn't always, have the answer that's on your paper, although your answer is probably right. A lot of times they're going to want you to rewrite this so it matches a choice. So let's just practice rewriting. I would say because this has a negative exponent, I can move it to the bottom. So I'm going to say I have 1 over 2 radical x plus, okay, my 2/3, my 2 stays on top, my 3 goes to the bottom. This has a negative exponent, so I'm going to put it to the bottom as a cubed root of x. Notice this one's a minus and a 3/4, so 3 stays on top, 4 to the bottom. This negative exponent is going to be the 4th root of x to the 7th. So again, you may have this answer, which is 100% right. It just may not be a choice. So sometimes you got to play around with it a little. Let's try a few more. All right, so there's our equation. Now remember, we need to rewrite. We are not jumping in, I can't stress it enough, till you see a variable to a power. Okay, unless you have that, we're not doing anything. So my goal is to rewrite this. All right, I need to have a variable to a power. Notice, not a fraction to a power, a variable to a power. So I'm going to bring this x up to the top, and that's legal as long as you make your exponent negative. And right now there's a 1 there, so I'm going to make this a negative 1. Minus, I have a 2. I want to bring the x squared up, so x to the negative 2. Plus, the 1 is there. I want to bring the cubed root of x up. Now remember, a cubed root is really x to the 1/3 power. So I'm going to say x to the negative 1/3. And then I have a minus. I'm going to leave my 3 and bring up an x to the, have you guessed it by now, negative 3/4. So again, we're implying some algebra skills there. Now that I have all variables to a power, I want you to take the derivative, pause it, see if it matches with mine. All right, I can quickly walk through it. Just watch my notation. Because I had y, I said y prime now. I brought my -1 down, subtracted 1, I got my -2. Brought my -2 down, which made this a +4, subtracted a 1, which got me a -3. Brought my -1/3 down, subtracted 3/3. -1 and -3 make -4/3. Remember, when I bring this 3/4 down, I'm picturing in my head is this over 1 times a -3/4. That's where my -9, or my, oh shucks, that should be a +9/4. Hopefully you've caught that with me. That +9/4, x to the -7/4. Now, like I said, one last time, we're just going to clean it up so we can match it up with the AP. All right, so how are they going to rewrite this term? Well, the negative exponent's going to go to the bottom, so the x squared goes on top, and I'm going to leave a negative, talking too fast here. The x squared goes to the bottom, and the -1 stays on top. Plus, I'm going to leave that as 4 over x cubed. Remember, this exponent's only on the x. Then I'm going to say a minus. I have a 1/3, and I'm going to move this cubed root of x to the 4th to the bottom. Plus, I have a 9/4, and I'm going to move the 4th root of x to the 7th to the bottom. And that would most likely be the choice I see on my answer page. All right, example 3. Notice this function is a fraction this time. I have g of x equals all of this junk divided by 3x cubed. Now, this is a special rule, and you notice I have these beavers down here, and we call this, and I'll go ahead and stick this in your notebook, make like a beaver and split. All right, beavers love to split wood, and that's why we're calling it make like a beaver and split. And this rule works, and here's the key, when you have one term in the denominator. All right, and again, that's a big Algebra 1 topic whenever you took it, but when you have one term in the denominator, you want to make like a beaver and split. All right, now what am I saying by that? Well, it's simple. I don't want you to use any fancy rules besides splitting. So I'm just going to go through and I'm going to divide every term I see by 3x cubed. Now the first time I do it, I'm going to write it out. Typically you would do this in your head. So I'm going to say it's 2x to the 6 over 3x cubed minus 6x cubed divided by 3x cubed plus 3x squared divided by 3x cubed minus 4x over 3x cubed plus 9 over 3x cubed. Get the idea? Make like a beaver and split every single term. Okay, now that I've split, we just keep playing that game of rewriting. So I'm not doing any calculus. Haven't done any yet, and I'm still not doing any. I'm just rewriting every term. I can't simplify 2/3, so I'm going to leave that. But I can simplify this. When you divide, what did you do with exponents? Hopefully you said subtract. So I get x to the 3rd. Again, I'm going to divide these, so I'm going to minus 2. Those will completely cancel. These 3's will divide into a 1, and I'm going to get x squared over x cubed is a 1 over x. Minus 4/3. I can cancel one of those, and I'll be left with 2 there, so 1 over x squared. And then 9 divided by 3 gets me a 3, and this x cubed is still sitting on the bottom. Okay, now again, eventually you'll start to be able to do that all in your head, and I'm going to write out one more step here, and again, I need to see everybody as a variable to a power. So I'm going to say this is 2/3 x cubed, I like that, minus 2, that's just a constant. This term I got to change. I got to bring that x up to the top. Its current exponent is a 1, so I'm going to say plus x to the -1. Minus, I can have a 4/3 coefficient. I need to bring this up, so x to the -2 plus 3x to the -3. At this point, I'm finally ready to do that one piece of calculus called deriving, or taking the derivative. All right, so why don't I pause it at that point? You take the derivative and see if it matches with mine. All right, I hope you're feeling confident in yourself. There's my quick answer. And lastly, I'm just going to rewrite it real nicely so I have what I think the AP would show. 2x squared minus 1 over x squared plus 8/3, and my x cubed is moved to the bottom, minus 9 over x to the 4th. Next quick example says find an expression for h prime of x. All right, well, I think we can run through this one fairly quickly. Everybody looks like a variable to a power. So I'm going to say h prime of x equals. Okay, so here's just that constant rule. 2 is just a coefficient, so I'm going to leave that. 2 times f prime of x. Minus the derivative of g of x is just denoted as g prime of x. Minus, can we do this in our heads yet? I'm going to say 6x squared plus 7, and of course then 0 on the end there. Real quickly, this one with a 7x, that's something you should be able to do very quickly in your head again. If I said y equals 7x and I asked you what the slope of that line was, could you spit out 7 very quickly? I would hope so. Remember, it's just a coefficient when it's linear. Just a few more quick examples to go. Using the information given, find the following. Given f of x equals this function, find f prime of 64. Okay, now, you're going to do this in the order you see it. I read f prime of 64. So we're going to do it in the order we see it. We're going to first derive. Okay, so we're finding the derivative. Then evaluate when x equals 64. Okay, but it's first derive, then plug in your 64. So hopefully you've got it by now. Like I said, pause it. See if you can get the derivative correct. So I've got mine, hopefully yours matches up. Now you'll notice before I attempt to plug in 64, I always clean mine up. I don't like evaluating things with negative exponents, so I'm going to rewrite this before I substitute in 64. I'm going to say this is 1 over 2 radical x minus 2 over 3 cubed root of x. Okay, now again, watch my notation. Once I have a derivative on my paper, now I can say f prime of 64 equals 1 over 2 radical 64 minus 2 over 3 cubed root of 64. Now again, of course, this is non-calculator. These are values you should know very quickly off the top of your head. The square root of 64, of course, is 8, so that makes 1 over 16 minus 2 over the cubed root of 64, again, is a number you should know quickly, is 4. 4 times 3 is 12. Now, real quickly, when you want to add fractions, of course, you need a common denominator. I could reduce that to 1/6 if I'd like. And I'm looking for a common denominator between 6 and 16. And 48 pops in my head. So I'm basically saying it's something over 48 minus something over 48. Well, 16 goes into 48 3 times. And 6 goes into 48 8 times. So I get a negative 5 over 48. All right, next example. Find the equation of the tangent line and normal line to the function at the indicated x values. So again, basically I'm reading, find the equation of a line. So the first thing that pops in my head, and hopefully it's in yours as well, is you need a point and a slope. Okay, so let me remind you, the point typically is, your algebra, and the slope is typically your calculus. All right, so what do you have so far? Well, you kind of have part of a point. You know the x value is 2. So we know it's 2 comma something. If you know an x value, it should take you about 30 seconds to get a y value. All you're doing is plugging in the number they give you. So I'm going to say the y value is equal to 2 times 2 minus 1 squared. 2 times 2 is 4, minus 1 is 3, 3 squared is 9. There you go, you've got your point. Now you need the slope. And again, slope is a fancy word in calculus to derive or take the derivative. All right, so your function is y equals 2x minus 1 squared. All right, before I take this derivative, my gut tells me I should probably do what with this function? You've guessed it by now, FOIL it, and then we'll take its derivative. So as I FOIL that out, I get, oops, where's my pen? 4x squared minus 4x plus 1. Hopefully you agree with that. All right, so now we'll take its derivative. Again, nice easy rule. 4x squared becomes 8x. The slope of negative 4x is just negative 4, and of course that's a constant. Lastly, I want the slope specifically when your x value is what number? What did they tell us the x value was? Well, 2. So I'm going to say y prime of 2 is equal to 8 times 2 minus 4. So this is my slope. I guess I'll write it slope. And this is my slope specifically when x equals 2. So 16 minus 4, I get a slope of 12. So as I put it all together, and let's be specific, the equation of my tangent line is y minus 9 equals 12 times x minus 2. So I just want a quick representation so you know what we're talking about in your head there. Basically, I want you to picture this upward facing parabola, and at 2, I have a slope of 12. So let's say here's where my point, well, we said it's 2, 9. That was the point 2, 9. I have a slope of 12, so hopefully I have a pretty steep looking slope. Now, of course, this picture was not drawn to scale. I did not plot any points, but I just want the idea in your head of what we're doing. We're saying at 2, we have a tangent line here that has a slope of 12. Now, the next part was to write the equation of the normal line. Okay, now, you've done this a million times before. Everybody but New York State calls it a normal line. We usually say perpendicular. So let's get in our notebook there. A normal line is perpendicular, that's our notation, to the tangent line. So you don't have to do too much. You just have to remember what the word perpendicular means. Now remember, it means opposite and reciprocal slope. Opposite and reciprocal slope. So once I know my tangent line, I basically know my normal line. I'm just going to take the same exact line that I have here and change my slope to the opposite and reciprocal sign. So the opposite of 12, or instead of opposite, perhaps you like the word negative better. It's positive, so I'm going to make it a negative 1/12 x minus 2. Okay, so again, you change the sign and take the reciprocal.